Hi, so today we are going to do ISI 2019 question number 2 group B. So the distributions of the marks is here 4, 5, 8, 8 A, B, C, D part. So let's see what the question is. So consider a concave utility function UCL where C represents consumption with L represents labor supply and this. And there are A, B, C, D parts. So I recapitulate the question in very precise manner. So let's understand this. You can pause the video to read the question. I summarize everything in the given part. So first of all, we should extract all the relevant information from this question. So first thing which is given is utility is a function of consumption and labor. Here L is the labor supply that a person is going for a work. Another thing is given the utility is increasing in consumption and utility is decreasing in labor supply. That is realistic in our day-to-day life. So this is the labor income, that is the wages multiplied with the labor supply. The person is worked in a firm, multiply its wages, that is equivalent to Y. We can also write this L is equal to Y by W. It is also given in the question. Now if we substitute this L in the utility function, then what will we get? U is a function of C comma Y by W. This is also given. So here also given P is the price of the consumption good C. L bar is a fixed total labor endowment, and so L bar minus L represents leisure activities such as playing games, watching movies, etc. So now the first part asked about the slope of a curve. So you all have to do all these things in YC plane. This is also mentioned in the question, so please be clear. So in this question, A part asks that what's the slope. So I assume that utility of C comma Y by W gives me some level of satisfaction. So I assumed here mu. You can assume anything like number 2, 3, 4, anything which is a constant number. So differential on the both sides for the slope. So it's very simple differentiation. You can see del U by del C into the change in C plus del U by del Y by W into the d Y by W is equal to d mu. So we know that the change in a constant will be 0. So we also know that the indifference curve property, indifference curve remains or indifference curve provides the same level of satisfaction throughout the bundle which lies on the same IC. So that's why du will become d mu will become 0, and since here W is a constant, so we can write W outside this equation. So the equation will look like this. So here 1 by W is a constant which is your wage rate, and d mu is equal to 0. So now let's do the simple algebra to separate dc by dy, which is a slope of your IC. So if we derive this thing, then we can get minus 1 by W into this ratio. So in the given part, Y by W is equal to labor supply, that is equal. So we can substitute it Y by W. So we can substitute it the L instead of Y by W. So we can get this thing. So this is the ratio of margin utility of labor supply divided by the margin utility of consumption. So it's also given in the question that margin utility from the labor supplied is negative and margin utility of consumption is positive. So the ratio of negative and positive will be negative, and if negative multiplied by this negative number, it will become positive. So this is the given part. Our dc by dy becomes positive. So that means our slope look like a positive sloped IC. But the question is that question is what's the curvature? Is it convex? Is it concave? In the question, it is given that utility function is concave. So if utility function is concave, then the level curves or IC indifference curves looks convex in XY plane or YC plane. So you can see the indifference curve on YC plane look like this. This is convex in nature. So the first part is done. Now let's do the second part. It's also very easy like this one. So second part asked about the optimal choice. You have to plot the optimal choice. So first of all, to plot optimal choice, we want to calculate budget line. So there can be two approaches. One is direct approach. I think it may be difficult for you, so I followed this indirect approach. First of all, find the budget line in two different commodities and then find your budget line in CY plane. So I assumed two commodities, one is consumption and another one is leisure activity. So if I add the total expenditure on both those commodities, then I get the I'll get my total expenditure will be less than equivalent to total income. That is my budget line. So first of all, calculate your total expenditure on consumption. So the price of consumption is P, so total expenditure on consumption is PC, and I assumed that P is equal to 1 for simplicity, that is numerator price, which that's why PC is equal to C because P is equal to 1. So the total expenditure on consumption will be C. Now the another commodity is leisure activity, and to do leisure activity such as playing games, watching movies, all these activities you have to sacrifice your working hours in which you can earn some money. At what wage rate? That is W. So basically W is the opportunity cost or price of leisure activity. So the total expenditure on leisure activity is the W into the amount of leisure activity, which is L bar minus small l, that is labor supplied, which we extracted this thing from the given part. So the budget line must be equivalent to total expenditure on consumption plus total expenditure on leisure activity, which is less than equivalent to total income. So what is the maximum potential income? Maximum income a person can earn if he do entire work, and if he do zero leisure activity, then he can maximum earn WL bar. So our budget line look like total expenditure on consumption plus total expenditure on leisure must be less than equivalent to income. So if I substituted these two things, then I'll get my budget line or budget set. So but we want to plot budget line in CY plane, but there is no Y here. So what we can do, we can substitute this L is equal to Y by W, which is given in the question. So since L is equal to Y by W, I substitute this L here. So I'll get this thing. If I open the bracket, then I get this thing, and WL bar is cancelled out. So I'll get C minus Y is less than equal to W, which is equivalent to say C is less than equivalent to Y. So that is the budget set, and that is a budget line. Now if we plot this thing in a CY plane, then we'll get a 45-degree line which has a slope 1. So we can see also the maximum potential income is WL bar. So the maximum consumption a person can do is WL bar because Y is equal to C. So maximum consumption WL bar. So this is our budget line. So this is 45-degree line, Y and C. maximum income is WL bar, and the maximum consumption at WL bar is WL bar. So this shaded area with orange dotted lines is the feasible region, or you can say this as a whole is my budget set. Okay, and this blue line is my budget line, which has one slope. So now we need to plot the IC. So IC look like this, but we must ensure that where will be the upper contour set, or where preferences are increasing. So it can be understood in this way also, because if you increase Y, that means you have to increase your labor supply. So if you want to increase your labor supply, that means you have to reduce your laser activity. So but utility is uh, related with your laser activity. Like if you watch movies, play some games, then you will enjoy, otherwise there may be some disutility. But it's given in the question that consumption is the margin utility will with the consumption is strictly positive. That means if you increase your consumption infinite times, your utility will also increase infinite times. So consumption always increase your utility, but Y is not increase your utility at some point of Y. After some point of Y, it will also decrease your utility. So the consumption pattern, we can see where the utility is increasing. We can see these two arrows. This will be the upper contour set, or the most preferred set of this preferences. So now we can simply see the where the optimal choice comes. It will be nicer, smoother tangential condition where the IC slope is equivalent, or tangent to the budget line, that is here. So you can see this is the point where your optimal choice comes, and this is the Y star, optimal Y star, and this is the C star. So if you solve the equation like margin utility of this utility function, that is margin utility from consumption, which is equivalent to marginal utility of Y, because the slope of this indifference curve is marginal utility of consumption. The slope of this must be equivalent to 1. That's why this has to be the condition for C star and Y star. But question didn't ask for this thing. Question asked just to plot, to show on a graph where will be the optimal choice. So now we have done the first part. Now another part, sorry, second part. Now the C part comes. So in this experiment, question says that suppose W bar is W dash is the new wage. I assume that W dash is the new wage rate. If W dash is the new wage rate, so in the question it clearly says that new wage rate is strictly greater than the old wage rate. So what will happen with the slope of or what will happen with the budget line or indifference curve? So let's start with the indifference curve. So we can extract the indifference curve slope. What we have derived in above parts is dC by dW, which depends on W. We can clearly see that. So if the denominator increases, that means our slope of IC will reduce. So the new slope must be less than, that means dC by dy at W prime is strictly less than dC by dy at W, which implies that our new IC must look more flatter than this red IC, and that's why the choice will be on the right side of this optimal point. So we can see this yellow IC is more flatter than this red IC. So slope of IC at W dash is more flatter than the slope of IC at W. So we can clearly see that. So from this analysis we can also say that consumer is better off because consumption and income both will increase. And what will happen to the budget line? If W dash is strictly greater than W, that means W dash L bar is strictly greater than W dash W L bar. That means if we plot this thing on the same graph, that means we'll get the W dash L bar and the maximum consumption W dash L bar. So area we can see is this small triangle and this yellow patch. So A, B, W dash L bar and W L bar is the area that we have gained in this experiment. So that means our new budget set, that is B dash, is greater than B, because B dash has more area than B, the area that is A, B, W dash L bar, W L bar. So definitely consumer must be better off. In realistic term, we can simply say that if I increase your pocket money, if I increase your salary, if I gives you more income, that means obviously your utility will also increase. So same preferences is in the question. So that means a consumer is necessarily better off in this situation. Now let's come to the last part. Suppose after tax, income will be y dash, which is equivalent to y1 minus tau. So y dash is your disposable income after giving the tau rate taxes. Disposable income is that income which you can dispose on consumption directly. So this is the initial case where there is no tax, but if the tax if there is tax, then your income for the consumption must reduce. So we can see y dash is equal to, because y is equal to W L bar, I substituted this thing in here. So this point must be shift to the left of this point. So but there can be two cases. First case could be, because it is not specified that what could be tau here, so I assumed if tau is not too much, it is like very small, then case 1 I assume that if W L bar 1 minus tau, that means tau is too small, then if it is greater than the initial choice, that is initial choice is y star, then we can see that our feasible region is reduced, but it does not impact our initial choice. Our initial choice remains the same. So in this case we can say that a consumer is indifferent with this experiment, and there will be no binding because this experiment does not change the consumer preferences that he was doing earlier. Now what if, that is the case 2, what if W L bar 1 minus tau is less than y star? So this is the case 2. So then your feasible region is reduced to this shaded area. Here this choice is no more longer. Now then consumer necessarily remains worse off. Why? Because you can see this choice C dash and Y dash is strictly less than C star, and Y star, Y dash is strictly less than Y star. So that means you will have less utility as compared to the previous utility. So that means consumer necessarily remains worse off, and I think that's all. But this case will be binding for his choice because it alters his preferences. Thank you.